I start the recording.
All right, let me try and bring in.
It would be great, yeah, if you share the screen.
Yeah.
That would be great. Perfect.
So are you seeing the first slide?
Yes.
Okay.
Yes. Yeah, that's the situation in the summer that many students go to internships and they mostly, do their job remotely. So that's the nature of the summer in our department, for sure. So not in the other departments.
But it's good to hear that that your students are getting exposed to the industry.
Yeah.
Should we go?
Yep. What do you want to start?
Sorry, I should start, or
Yeah,
Yep.
you can go ahead.
Jawad, you want to introduce, start, Garrett, and starting the webinar first? We can have a kind of 1 or 2 minute introduction.
Okay, I just want to give an introduction about our webinar series, Mackay Mining Matters series. We started in March, and we're having like 1, sometimes 2 presentations per month. And we're trying to address the main topics or hot topics of mining industry. In our previous webinars, we had speakers from lithium industry. We had speakers from Komatsu about their autonomous systems. And today we have Garrett with us. Garrett is from Geovia, which is part of Dassault System course, and their 3D experience platform. It's a kind of very futuristic, vision to the mine planning software packages. We're gonna learn more about that platform today. And usually, and that's the case for this webinar as well, except one of our webinars that we had some intellectual information on it, we were not able to publish it. We have published pretty much all of our webinars on our LinkedIn channel. If you don't have access to our LinkedIn channel, you can simply search UNR Mining and Metallurgical Engineering Department on LinkedIn, and that will bring you to our LinkedIn page. And all webinars are recorded and posted after the webinar for offline visits. I'm leaving, Garrett, your background to yourself to introduce where you're coming from. How did you end up in Geovia, and what is the 3D experience platform?
Excellent. Thanks, Javad, and thank you for the invitation to Geovia and Dassault Systems to speak today about what we view as really the future of mine design, both in the open pit, underground, and block caving environment. And so that's what I'm going to spend a little bit of time on today, right? Is essentially discovering the parametric advantage in mine design. So table of contents, I'll briefly introduce Dassault Systems. I'll describe our mining portfolio and the solutions that we offer to the mining industry within Dassault Systems. Then I'd like to talk about the difference between traditional versus parametric design, followed by an introduction to our surface mine designer role and its advantages. And lastly, I'll cover our parametric underground mine design solution. Okay. So first, a little bit about Dassault Systems and myself. So we are what is called the 3D Experience Company. It's a French organization, and we are really a purpose-driven company. We think of progress and innovation in terms of the balance and impact that we have. So as we create value, we always take into account what we are taking from our planet, right? And so harmonizing product, nature, and life really lies at the heart of everything we do and the tools that we bring to the world. So we have about 20,000 really passionate people from 135 countries across the globe, right? And these are really the heart of the company, right? And these people, right, we share similar values and we have similar passions, right, for innovation and doing things in a better way. So we also have a large R&D team, right, connected across 72 different laboratories globally. We have more than 300,000 customers in the various industries that we serve worldwide. You know, and a fundamental aspect of Dassault Systems, or what we call 3DS, is partnering with clients and academics, right, who are leaders in their industry segment, on top of the cutting edge technology. And really, they're trying to answer tomorrow's market needs. And these can be anything from industry reference, companies to startup type organizations. We also leverage about 15,000 different selected partners, so independent businesses that partner with Dassault Systems, right, to essentially increase our collective knowledge and reach in the various areas of technology that we deal with, their sales and services, education, and research, right? And so an important point about Dassault Systems is the composition of our shareholding, right, has been really consistent since the introduction on the various stock markets, right? And the majority of the company is owned by what we call the Dassault family and essentially the senior company management. And this stability enables a consistent long-term strategy and long-term investment, right, that enables us to be one step ahead of the competition. So we're not so exposed to quarterly market reports, I would say. And here you just see on the globe in the US, I'm based in Denver, Colorado, out of our what's called the Broomfield office. And a little bit about myself. In a little less than, I'd say, 3 decades of my experience in the geosciences, I've gone through many industry highs and lows, and these highs and lows have definitely impacted my career. And you can see I've been involved in, I would say, upstream oil and gas, geothermal, and mining on 3 different continents, right? So speaking to UNR students, right, I think studying at a top-notch mining program like UNR can really help mitigate some of your exposure to these industry cycles and for your careers. But don't imagine for 1 second that you'll be immune to these industry cycles. It's a dynamic world out there, and being involved in the mining industry is just it's part of your career. So, however, I think that mining and critical minerals in particular are going to continue to have very strong demand globally. And so your career should benefit from that in the near future. And so I've spent a lot of time in my early career at national labs, conducting research and supporting research in the geosciences. Spent a lot of time, a decade at Schlumberger on 3 different continents, carrying out geophysical type roles in client-facing business development. My geophysics career and geoscience career continued with a number of niche service providers. And now I'm with Dassault Systems and Geovia, really trying to advance and bring in advanced technology to the somewhat laggard mining industry. It's been a great adventure, right? Experiencing other cultures and parts of the world. And this is just a plot of some of my work-related travel history and flights, not taking into account road trips in Europe, Australia, and the US, right? And so it can be a very dynamic career. And if experiencing new things and excitement and constant change is what you want out of a job, the mining industry and the resource industry in general is a great place to have a career. So back to a little bit about Dassault Systems. We have really a profound belief that the virtual world extends and improves the real world. So and achieving a more sustainable future is only possible really by leveraging virtual worlds. So in life, there are no rehearsals, if you will, and we need to build these virtual worlds, simulated environments, and model these things to be able to evaluate impacts before either producing a product or taking a decision on a business process. And so these virtual worlds really help people imagine things differently. So we aim to inspire and really help customers create and build a more sustainable world, right? It's not only, it's for people at home, for people at work, and to create really smarter places to live, right? For citizens, for managing resources, for managing energy, and taking a long-term view of all of these things, right? And so essentially, we at Dassault Systems are committed to using virtual worlds to help better understand and simulate how products, nature, and life, right, can interact in harmony. And this is one of the main reasons that Dassault Systems is named the 3D Experience Company, right? Being a purpose-driven company also translates into a high level of market confidence and trust. And naturally, the software tools and processes that we and our customers use really allow for an improved way of doing things, you know, by carrying out simulation in these virtual worlds and allowing what-if analysis, right? So the 3D experience really simulated by this compass here, it really powers our 12 brands. And it's broken up into according what they really stand for. We have social and collaborative apps in the north part of the compass. We have 3D modeling apps in the west part of the compass, simulation apps in the south, and information intelligence in the east. And we essentially, through these different brands within Dassault Systems, we serve primarily 12 different industries, you know, with tailored solutions to address their specific challenges. And Geovia specifically provides value in the 3 sectors outlined here in the dotted line currently. And so what Geovia does is we aim to provide end-to-end digital solutions, right? We're focusing on the intersection of natural resources, infrastructure, and urban planning with our tools. We really empower and work with a diverse community of geoscientists, earth engineers, urban planners, really, and it's about developing tools and working with them to ensure the responsible use and development of Earth's resources. And the way we do that, right, is through the 3D Experience platform. The tools we create are essentially virtual twins of different business processes, subsurface infrastructure, right, that enable users to analyze, visualize, and ultimately make better decisions on processes and activities that they're going to carry out. So Geovia's vision, right, is to model the sustainable future and the sustainable planet, right? And the tools that we build in Geovia are all focused towards that portfolio. And so what is it that we do? So we've developed a portfolio that essentially spans the entire mining value chain, right? From discovery to rehabilitation. Our industry process experiences, as we call them down here, right? They really are set up and categorized to address the whole mine life cycle, right? We have capital facilities and information excellence, right? Resource portfolio evaluation and modeling, strategic mine planning and design, which will take a deeper dive into the strategic mine planning and design IPE. And then we have more the mine production and distribution scheduling in the tactical and execution space. So our cross-brand solutions, right, really enable the mining businesses to unlock sustainable value, not only by focusing on geologic and mineral processing, but also cover the project governance, the work management, the immersive visualization, the multi-stakeholder collaboration tools that are required. And drawing on our experience in the civil engineering and construction industries, right? We've developed a parametric mine design tool, right? That uses the 3D Experience platform and one of our sister brands called CATIA in their 3D design applications. Now, traditionally, Geovia has been known for our products, and we're going through a bit of a transition now. You've probably heard of Surprac, Whittle, Mineshed, PCBC, Minex, right? We essentially have transferred all of these product-based type offerings into more functional role-based offerings, right? Culminating around geoscience modeling, mine design, and mine operations. And that covers a lot of the functionality that we saw within these different products. And then other functionality, right, is directly translating over into the 3D Experience platform. So on this journey, I would say we're somewhere, you know, it depends on the functionality, but we're somewhere along the spectrum. But the ultimate goal of Dassault Systems and the Geovia brand is to move away from just these desktop-based individual solutions, individual software programs, right, into more of a functional role. And in the future, the Geovia portfolio will leverage tools from all of our different brands, right, within the mining environment. So leveraging the structured collaboration and project management tools of the north side of the compass, obviously the 3D modeling apps on the west side, the multi-physics simulation and geotechnical work that's done with Simulia is already integrated in some of our solutions. And then also information intelligence and being able to communicate and understand current market trends and stuff. These will also be important in the collaboration within the 3D Experience platform. So moving on and coming back to the future of what we see of mine design, let's look at the comparison between traditional and parametric mine design tools. So looking at the concept of parametric mine design, let's see how to accelerate the creation of underground mine and open pit designs. So a successful mine design depends really on two things, right? Gathering all the available geologic and geotechnical, mining engineering, mineral price, regulatory information, and creating a design that efficiently, economically, and sustainably accesses, you know, the mine production areas. However, it has been a manual, time-consuming process. You know, traditional CAD-based mine design, although powerful, right, it can take very long to produce, And that data, it may already be out of date by the time it's finished, right? The mine planner or mine design engineer must then build a whole new design to incorporate the latest knowledge, using up still more valuable time, potentially days or weeks of manual work. So we have worked on automating some of the process, right? So taking inputs such as geological solids or ore bodies and creating templates for things such as level access, ramp designs, stopes, or ring designs. We can connect these through a ready-made role with different apps or functionalities, or custom templates, if you will, parameters and some custom scripting. And parametric mine design, right? It can eliminate some or maybe even the majority of the manual work that's required in CAD-based design, right? And this allows mine planners to create a number of potential paths or designs rapidly and quickly to make an essentially equally infinite number of refinements to reflect changing data as it comes in, all without losing previous design work. So we get a parametric design model that will automatically update when we change a parameter. So we're leveraging traditional CAD, right? But we're just automating some of the steps within. And ultimately, right, a change locally will cascade through the whole design, allowing us to do analysis of essentially different scenarios very quickly, right? And ultimately, this reduces the design cycle time from months or weeks down to hours or minutes, right? So that's what parametric design is all about. So what's the advantage of this automation, right? Traditional design is, a mining industry standard, and there's lots of expertise and, built up over the years and empirical know-how. And there's a large pool of mining engineers who, study and perfect their skills through university courses with this design experience. However, our customers and the mining industry in general realize this is a real time-consuming manual process. When a change is required, a large portion of a design needs to be then redone. So a change in a bench height, for example, or a ramp inclination or a vent raise, right? It can result in potentially a month of rework, right? And so it doesn't allow for a quick analysis of multiple scenarios. The parametric design, on the other hand, allows for speed and accuracy. Once you have a model built, you can change what you want or update any of the parameters, and you can do it and create a new mine design relatively quickly. And this time saving really helps with reducing the demands on an already resource constrained industry, right? Mine engineers can quickly make changes and be freed up for other important tasks. Again, these tools they're not really meant as a replacement for a skilled mine engineer, but they will help you become more efficient and allow you to explore more of the solution space, if you will, in designing the mine and its evolution over time. So another important advantage is that the design knowledge is captured in the templates rather than with individual employees, right? And so this allows for safer and more accurate design knowledge to be captured by the company and not lost when someone leaves or is promoted into a new role. So one con that can be a concern is the time and investment it takes to build a model up front. Yeah, there's no way of stating it pretty, but it does take time and effort. But in our experience, it easily pays back itself in a relatively short time frames, and certainly over the life of a mine. So let me now introduce, the Dassault Systems Geovia Surface Mine Designer role. It's really built on the 3D Experience platform that I mentioned earlier. So it's all, you can think of it as cloud hosted, right? And it's a collaborative environment, right, that connects all the users together We have a centralized data storage in the cloud, which means a single source of truth. So you're not using an outdated emailed file that you received last week. And we can also communicate and structure and have structured collaboration and project management tools associated on this platform. And what this does is it gives us a catalog of applications, right, for mine design or simulation, right? And these applications are, they can be defined by a person's role within the business. So they only get access to certain functionality or applications, required to execute their role. And in a typical workflow for parametric mine design, in an open pit environment, for example, we start by setting up the mine site definition, setting up a common structure for the operations, safety rules, naming conventions, etc. Then we can import and validate the key mining data, the geologic model, the surfaces, polygons, etc. Anything required, as information for the design effort. Next, we can define the design base on these parameters and assumptions. And we can then generate our designs, right? The templates that are all linked up and different scenarios can be built by varying essentially the connected parameters. So finally, we can share these target scenarios with our colleagues in management, right? They can visualize, review, and validate final designs all on the 3D Experience platform without actually having to access the design application complex functionality that was used to generate this, right? So this process flow really delivers the advantages in that it automates and accelerates the data consumption in mine design process. It allows you to capitalize on the design knowledge skills, right? And it can assure some sustainability in your efforts. There's really the advantage of it generates consistent and 3D mine design models. So it's not so, I would say user compartmentalized, right? And it can really facilitate the data interrogation and scenario analysis, right, in order to test mining hypothesis. So now I'll run a video covering the highlights of this role. You can see how it can parametrically generate multiple outcomes to identify optimal designs, right? You can include pit slope standards and geotechnical criteria to develop safe designs. You can develop technically robust pit, dump, and ramp designs linked to physical constraints and geotechnical features, right? It also provides transparency and data model continuity between optimized pits and practical designs, and you can significantly reduce your design time. So the automated parametric process can be used to essentially generate and evaluate multiple pit, pushback, and ramp designs with this role. And right, so you can essentially define default bench heights, right? Plus berm types, bench angles, berm widths, and how they are repeated, right? And then ramps can be designed from the top to the bottom, clockwise or anti-clockwise, with an outside or inside profile, and whether the parameters are from the pit design or customized, right? And then once a parameter or parameters have been adjusted or modified, the design updates automatically. Right? And adjustments can be made to specific ramps, right? Including the berm access, the taper distance, switchback location, the inclination or ramp rate, right? The width, radius. And then geotechnical zones can be configured, for safety and will automatically adjust the benches. They can be based on the region, the volume, the contour, right? And the role also includes dump and stockpile designs with ramps, including the entry points, right? The solution, it provides improved haulage efficiency, right? Through a ramp smoothing process. And it can also create safe pit designs, right, through pit wall smoothing algorithms. That'll come up in a second. And so you can see how this parametric process, right, is automatically updating this open pit design, and it's very efficient compared to traditional methods. And lastly, it can also create safer and more efficient pit designs and practical pit designs through, essentially bench string modification, right? So we're going to essentially connect these two bench profiles. Okay, so really the surface mine designer role provides the advantage of optionality, right, and assessment and identification of optimal designs through rapid generation of multiple outcomes for your pit, through this parametric design process. It allows consideration of safety standards, right, related to pit slopes and geotechnical criteria, by generating pit, dump, and ramp designs that consider the impact of this geotechnical criteria to the pit slopes and the benches, right? And it unsilos that information from one individual user. So a further advantage is that it ensures pit, the dump, and the ramp designs are technically robust by considering all the physical constraints, including the geotechnical features, right? And importantly, the surface mine designers, it really delivers a seamless process and data model continuity between these optimized pit phases and practical designs, right? And this really leads to significant time savings and transparency in this process. So it really addresses multiple business challenges, right? It allows you to plan for the safety of your people and equipment, right, by ensuring the mine designs that they honor the geotechnical constraints, right? And this demonstrates that you're addressing increased focus on health and safety. It can allow you to, it really allows you to build value-based planning and to minimize the waste handling across multiple horizons and deliver on performance metrics and return on investments, right? And it demonstrates that you're really addressing increased, stripping ratio and rising input costs. And lastly, it really plans for sustainability, right? It allows you to make a positive, or let me say, less negative impact on the environment, and it employs good governance. So it demonstrates that you are addressing, your ESG priorities. So what this surface mine designer role really allows you to do is rapidly generate safe and practical pit, dump, and ramp designs. And it's quite an interesting tool. So let's move underground now to an example of a long hole stoping operation that's looking at the electrification of the mine. And this client was not really sure of the impact on different equipment that it will have on the drift size, the ramp gradient, offset requirements, etc. They want to try out different options and quickly update the mine design and be able to analyze different designs and figure out a way forward. So in this video, what you're going to see is that as we update and change any of the parameters, in this case, the entire design is fully updated. So, excuse me, we're using 5 different templates for ore access drives, level accesses, ramp gradients, exhaust and charging stations, and escapeways, right? So coming up in the future here, right, you can see how the mine design is automatically updating. And ultimately, we want to change the access level spacing. that's increased from 30 to 40 meters. I think that's coming up in a second here after we change the incline. So yes, here we're going from 30 to 40 meters, right? It automatically updates the ore drive, the level access, the charging stations, and the escape ways, right? If traditional manual methods were used in this case, it could take a month, right, to do all this work. And with our parametric mine design solution, it really only takes a couple of minutes, right? And so this is a radical step change in the approach to mine design. The solution, it also captures the output parameters, right, that are calculated automatically when we change one of these input parameters. So for example, when a ramp angle is changed, the total length of all the development increases, right? Or decreases sometimes. We can also include volume, cost calculations, or any other key parameter required, right? These are all controlled essentially by a series of scripts. And additionally, right, it can output these 3D models, right, and center lines for use in downstream processing, right, such as tactical scheduling or more short-term scheduling, whatever you might require for the future. Sorry, and on to a case study where we've employed parametric mine design. And we were working with Hecla, and in fact, there's a webinar that's been delivered on this specific project that goes more in depth, and I'll just give you a brief overview of it today. Hecla's Lucky Friday ore body in Idaho is roughly 4,000 by 2,000 feet along strike. It has a lot of legacy workings. It's a really large area for them to design for. Right, and that's coupled with they're also changing to a new mining method that they've determined to be more efficient. And typically they do an annual update, right, on a long-range strategic plan just once a year. And what they really needed was to quickly evaluate different design permutations, right? Essentially, they wanted to understand, if they do this, what does that do, right? And when we applied parametric mine design tools to this challenge, right, the outcome essentially was a significant reduction in the design process for them, from weeks to hours. So, and in essentially some of the low-hanging fruit that we aim to address for Hecla specifically was to look at automating some of the elements of the design at the Lucky Friday with the number of spirals, the spacing of the spirals, and the number of access or slot points per ramp segment. So I'm going to show a video here. Essentially, these are the stopes that we, sorry, I need to play this video. These are the stopes that we started out with, and we bring in a reference surface. And this reference surface really represents a comp surface where the development needs to intersect with the stopes. And so we take this input information, we run the scripts, right, that were I guess generated for this specific use case for Hecla, right? We're making use of stopes and elevations. And what this script has done, right, is it creates all the point intersections. And then it creates the development lines coming off those intersections. After that, it creates the double slots where a single ramp, accessing essentially two sets of cuts. And then it finalizes all the development within that. We can then export the string files to our tactical scheduler, right? And this essentially, this parametric advantage has allowed Hecla to rapidly evaluate multiple underground designs. And in this next slide, I want to put in or propose a hypothetical case, right, or a target use case. And apologies for the lack of making this slide look pretty, but it's a concept that we're working on actively and we're just in discussions last week on. But so with parametric mine design, right, I want to demonstrate the power of these tools. So in an open pit case, right, you have an input of a pit design with associated waste dump and tailings and storage facilities, right, that are all designed based on, right, sort of what the pit looks like and what the long-term strategy is. However, let's say you had to do some reassessment of slope configuration, right, due to encountering some, poor rock conditions, essentially updating your geotechnical parameters. You'd have to, what you do in the parametric case is, right, you'd input the new slope parameters into the Mine 3D design app by, essentially editing a slope parameter. The pit design would then automatically be regenerated based on these updated parameters. In the fourth step, right, the new pit design would be automatically evaluated against the resource block model, okay? Then in the fifth step, right, because these are linked, right, you'd want to update your waste dump design. And this could be a parametric automated process, right, based on the new waste content of the updated pit design. And then ultimately, right, you could update your tailings storage facility. And tailings retaining walls, right, can be automatically redesigned based on the new tailings volume from the pit design, right? So this is a hypothetical case, but you can see the power that these parametric tools can have in the mine design process. And again, we don't aim to replace skilled mine engineers, right? We want to arm you with the latest tools to really improve outcomes for the sustainable extraction for natural resources. And lastly, I like to end all my presentations with a slide, a pretty picture slide. Here I am underground at Hecla's Lucky Friday mine at the ore face in their narrow vein mining situation. This is the ore that they're chasing. And lastly, the video is just of a loader, right, that was mucking out one of the freshly fractured thin seam veins. So thank you very much for your attention. Open to any questions you may have.
Thank you, Garrett. It was really, really interesting to me. I'm not a mining engineer. I'm a metallurgical engineer, and I do sustainability. And I loved your presentation. And I have one just suggestion. So you showed on the slide number 28 that one of the targets, one of the goals is enhancing ESG and sustainability. Mm-hmm. So that is my suggestion. If using, parametric mine design can give us kind of, optimized system in terms of, designing a mine, what if you add a feature in your software tool to quantify the CO2 emission?
Yeah, it's certainly been an active discussion. So these were what I reviewed, right, was specifically parametric mine design tools within our portfolio. Within our portfolio, right, so I was in what we call this industry process experience, strategic mine design. We have another IPE, industry process experience, called strategic mine planning, and this is where we're actively working, right, over the life of mine to incorporate essentially CO2 emissions, the difference between electrification, and how you would optimize these different processes and decisions for each specific mine.
Exactly. When you change one parameter, you will see the changing in the CO2 emission in the system over
Correct.
the life
Yeah.
of the mine. So that
And
would be really, really interesting.
Yeah, and really, you know, addressing this in the virtual world, right, or what we call a virtual twin, is really the only way to optimize and answer that question. And that's why I'm so excited about working for Dassault Systems. I think the tools that they're bringing to market and their approach to the market are really game changing.
Yeah, that would be great.
Garrett, I have a big list of questions. I don't know if you have time to go all through. I may show up in your office in Denver and discuss all. When is your next user conference? I think.
Yes, our next user conference is actually for North America is scheduled next week in up in Vancouver.
Oh my goodness, that's too
Yeah,
short.
so unfortunately, I won't be able to attend the Elko Mining Expo in your home state because I have my presence is required up in Vancouver for that event.
Oh yeah, I was thinking about to attend that, but next week is going to be tricky. I've already committed to go Elko. Garrett, this slide that you have right now, it's really exciting, but can you tell us like kind of timeline when we're gonna be having some of these products for the industry to use?
Yeah, okay, so the Surface Mine Designer role that I briefly previewed, that's available now. That's ready for prime time. And there are that's available to license on a on-premise cloud or true cloud nature right now. And there's obviously added functionality coming in the future associated with that. I would say in the more complex sort of underground parametric design tools, I would say that's more of a customized service at this point because they tend to be more complex than some of the I would say more open pit templates that we've developed so far.
And we have at UNR the university license for Surpac, Mineshed, and Whittle. And is this platform still open for university licensing as well?
Absolutely. We champion and partner universities, and we let's have a discussion offline, Javad, on how we can enable some of these tools for you and your students.
Yeah, that looks very exciting. One of my students actually is online here. I remember one time we were designing a copper mine, and I gave him the assignment, and he designed like 50, 60 times a pit to reach to an acceptable, design. So seeing this, and you just change the parameters and do it interactively like that, it's like a science fiction.
Yeah, again, we're not trying to replace skilled mine designers or mining engineers. What we're doing is we're offering more efficient tools, right, and capturing their knowledge and ultimately freeing up their time to take on additional challenges, right?
Yep. Garrett, I believe with this 3D experience, we need a lot of more computational resources. I believe cloud is going to play a big role here.
Yes. Yeah. I mean, most of our solutions are cloud enabled. A lot of our clients, when you say cloud, there's a lot of different jargon and terminology, but I tend to categorize it either in on-premise for essentially clients that are more concerned about security and want to have their own data silo or their own cloud within house, and then a true cloud environment where it's hosted either on our servers or Amazon servers or whatever. Yeah.
So I'm just curious if we need to replace all the computers in our computer lab or not.
I would say not. For example, for our truly cloud-enabled solutions, right? You can almost achieve everything that you need to do with an iPad, and so you don't necessarily need a heavy number cruncher desktop to achieve some of these solutions.
Garrett, I didn't hear that much about AI here.
Good question.
Have any plan to somehow bring intelligence to all these designs?
That's a good question. I'm sure that that our organization is actively thinking about it. How we would incorporate that in the parametric mine design world, it's not clear to me at this point in time. I think that's probably a question that needs some discussion at various conferences, right? And
Yeah.
we'll definitely need
I'm
input from academics like yourself.
I'm just imagining an ideal world that, lots of users designing their mines, and you have probably access to some sort of data, how they're designing their mines. And then you can use that data to develop AI platforms, to put all these knowledge together for a much smarter designer.
Yeah, I mean, once you build up a library of templates, right, if you will, for a parametric process, that seems like certainly something that could be achieved relatively easily once that library exists.
Garrett, in this slide that you have right now, the strategic mine planning bar, you have the Whittle platform, and that's probably my most interesting part in mine planning. I did my PhD in this field. Whittle has been Whittle like since 2000. Last 20 years, there has been pretty much no change to mine optimization. And Geovia probably is the only company has the PCBC. So pretty much there is no underground optimizer at all in the industry. I don't know why. Is this kind of business behind it, or can you elaborate more if there is any plans in the background going on, and we will have more strategic mine planning tools in the industry?
Yeah, well, I'm not exactly clear on how much I can discuss and disclose here. But let me say that Whittle is a very powerful algorithm, right? And specifically for its open pit optimization tools that it's well known for. However, there is R&D efforts, right, to improve on Whittle's algorithms and strategic mine planning tools. That's specifically for the open pit optimization type scenario. And then PCBC that you mentioned earlier for panel cave, block cave type scenarios. There's active R&D within our organization, right, to essentially bring those tools to the 3D Experience platform, right? And ultimately, once that is there, we will then be able to leverage all of the multi-physics simulation with the Simulia brand and geotechnical simulations, right, to essentially have a multi-brand solution for block cave, mine design, and mine planning. So I would say we're translating that functionality of PCBC and WDL, right, into the 3D experience platform, but then we will benefit from all of the other functionalities within the platform and brands within Dassault to make that process more smoother, automatic, and essentially apply structured collaboration, project management tools to improve the whole business process in the strategic mine planning world.
You know what I'm curious more about this is there's been like 30 years of research and development in academia and some mining companies, some companies, you know, software companies, and still none of those developments are available commercially like a tool for people. WDL like is based on an algorithm Lerch and Grossman developed in 1960s, and we're still using that. And although WDL was the first one, but I can say Maptech or you know, MineSight, all other competitors, they use the same algorithm. They haven't deviated. They haven't explored the other areas.
Yeah, so within WDL, right, we do have the LNG algorithm, but we also leverage the pseudo-flow algorithm, and then also the simultaneous optimization, or SIMO is known in yeah, okay.
There are groups of a lot of people actually in academia working on bringing the stochastic modeling instead of a deterministic look at the design, and bringing the uncertainties of our exploration, block models, and even the you know, stochastic nature of other technical parameters, geotechnical parameters, or metallurgical parameters into design. It's still there's not any tool in the market incorporating all these things to the design. Is there any plan in Dassault in that regard?
Let me say that we are aware of this. We are looking at all these different algorithms, and also we're aware of what our competitors are doing. My answer to you, Javad, would be, it sounds like a pretty good business opportunity, right? That if you wanted to develop a program, or potentially work with an organization like Geovia, right, to help develop that program, it sounds like it's an opportunity within the mining industry.
Great, Gareth, I appreciate all your elaborations.
Excellent. Thank you for the questions. Are there any other questions? I'll take that silence as a no. So let me take the opportunity again. Thank you everyone for your time and attention, and the invitation, right, to share this small little portion of what Dassault Systems does in the mining industry with UNR today.
Perfect, I appreciate that.
Thank you, Gareth. Thank you so much for joining us. Thank you.
Okay, thanks everyone. Have a good day.
Thank you.
Thank you. Have a nice day. Bye.
Bye.